All right, so you want to really dig into Dockerfiles, huh? That's what we're doing in this deep dive, going way past just the
Yeah,
basics.
we're going to get into the nitty-gritty today.
You already know the building blocks. Now it's time to become like Dockerfile architects, right?
Exactly. We're going to be looking at optimization, best practices, even security stuff you need to know.
All right, well, let's get into it then. You always hear people saying that Docker files are declarative. What does that even really mean?
That's a great question. It's actually a really important concept to grasp.
And why should anyone care?
Yeah, for sure. When we talk about a Dockerfile being declarative, we mean it's more like you're describing the end goal, what you want the final image to look like, instead of like writing out each step-by-step instruction to get there. Think of it this way. You're not focused on the how. You're focused on the what.
So instead of giving someone a recipe with all the mixing and baking instructions, you just hand them the finished cake.
Well, not exactly.
Right.
There are still instructions. It's more like you're handing them a very detailed blueprint.
Oh, okay, I see what you mean. But Docker still needs to follow some kind of order to build the image, right?
Right, there's definitely a sequence. The cool thing is Docker's got some tricks up its sleeve. It can actually optimize the entire process for us in the background.
Oh, wow, that's really cool. So how does it do that?
One of the key things it does is caching. So let's say you just tweaked one tiny line of code in your app.
Right.
Docker's smart enough to see that. And it'll only rebuild that one little piece that changed instead of rebuilding the entire image from scratch. Saves a ton of time, especially when you're working on something big.
Wow, so it's only rebaking that one ingredient we talked about, not the whole cake.
Yeah, exactly. It's like magic, but it's really just clever engineering. This caching thing works directly because Docker files are declarative. Docker reads the instructions, sees what depends on what, and then figures out the most efficient way to build everything.
So is that the main advantage then? Just faster builds?
Well, it's a big one, for sure. But there's more to it. Think about trying to read a messy script versus a well-organized list. Docker files are kind of like that organized list, especially when you start dealing with these complex builds. Makes it way easier to understand and maintain.
Okay, yeah, that makes sense. What are some other benefits of Docker files being declarative?
Well, because they are so well-defined, it means that they are incredibly reproducible. So you can take that same Docker file, use it on any machine, and you know for sure it's going to build the exact same image every single time.
So no matter who's building it or what system they're on, the result is the same. That's really powerful when you think about it.
Right, and that's why portability is another big advantage.
Okay, now you're speaking my language. This is super helpful for anyone who's ever had to troubleshoot environment inconsistencies between development and production.
It's a game changer. And it all stems from this declarative approach. You define the what, Docker handles the how.
That's brilliant. Okay, so we've covered caching and reproducibility. What else?
Well, this might seem like a small thing, but because Docker files are so readable, they lend themselves really well to automation.
Oh, interesting. I can see how that would be a natural fit.
You can easily integrate them into your CI/CD pipelines. You can version control them just like you would your code. It streamlines the entire development workflow.
Okay, you've definitely convinced me. Declarative Docker files are the way to go.
Absolutely. They're a cornerstone of modern software development. And when you understand the why behind the how, you unlock so much more potential.
You're preaching to the choir here. So we've talked about Docker files being declarative, but I'm curious, are there any downsides or trade-offs to this approach? Are there ever situations where a more imperative style might actually be preferable?
That's a really insightful question. It's true that the declarative model isn't a silver bullet. There are edge cases, particularly when you need extremely fine-grained control over every step of the build process.
So for the vast majority of use cases, the declarative nature of Docker files is a huge win.
Absolutely. But it's always good to be aware of the trade-offs. Sometimes you might need to get your hands a little dirtier.
You've got me intrigued now. What are some examples of those edge cases where you might need to deviate from the declarative approach?
Well, let's say you're dealing with a legacy application that has some really specific, maybe even quirky build dependencies.
Oh, okay, I can see how that could get tricky.
You might need to insert some manual commands, maybe even interact with the host system during the build.
So it's not always a set it and forget it kind of thing.
Exactly. But even in those situations, the declarative parts of your Docker file will still provide a ton of value in terms of readability, reproducibility, and maintainability.
That makes sense. So it's about finding the right balance for your specific needs.
Precisely. Dockerfiles are incredibly powerful tools, and like any tool, understanding their strengths and limitations is key to using them effectively.
Well said. All right, so we've covered a lot of ground already on this whole declarative aspect of Docker files. What other Dockerfile mysteries are we going to uncover today?
Well, one thing that trips people up, especially as their applications get more complex, is this idea of multi-stage builds.
Ah, yes, multi-stage builds. I've heard the term thrown around, but I'll admit I'm a little fuzzy on the details.
Well, let's demystify them, shall we? They're all about building super efficient Docker images. Like, imagine you're building a Java application, and you need a whole bunch of tools and libraries just for the compilation step. But once it's compiled, do you really want all that extra baggage in your final image? Probably not.
That makes sense. It's like leaving all your tools and scaffolding lying around after you've built a house.
Exactly.
Yeah.
You want a nice, clean, efficient final product. And that's where multi-stage builds come in. They let you use different base images for different stages of your build process.
Okay, so you're saying I could have one stage for compiling my code with all the necessary dependencies, and then another stage for actually running the application with just the bare minimum.
You got it. You're basically shedding unnecessary weight as you go, resulting in a much smaller and more efficient final image.
That's incredibly clever. So it's all about optimization then?
Optimization is a big part of it. But there are security benefits too.
Oh, I didn't think about that. How so?
Well, the smaller your final image, the less surface area there is for potential vulnerabilities.
That makes sense. Fewer components, fewer things to go wrong.
Exactly. And it also makes your images more portable and faster to deploy. It's a win-win-win situation.
Wow, multi-stage builds sound like a game changer. I'm excited to dive deeper into those. But before we do, I want to circle back to something you mentioned earlier about Docker files being more readable and maintainable.
Absolutely. It's one of the often overlooked but incredibly valuable aspects of Docker files.
I've definitely seen my fair share of Docker files that look like cryptic shell scripts. How can we avoid falling into that trap?
The key is to treat your Docker files with the same care and attention you would your application code.
So think of them as a first-class citizen in your project.
Exactly. Use meaningful comments, follow established conventions, and don't be afraid to break down complex builds into smaller, more manageable chunks.
Are there any specific Dockerfile instructions or best practices that you find particularly helpful in this regard?
Oh, absolutely. One of my favorites, and one that I think is often underutilized, is the .docker ignore file.
Ah, the Docker ignore file. I've heard of it, but to be honest, I haven't really explored its full potential. What's so special about it?
Well, think of it like a superpower for keeping your Docker images lean and mean.
Lean and mean. I like the sound of that.
Yeah. It's all about being intentional about what you include in your images. The Docker ignore file lets you specify files and directories that you want Docker to completely ignore during the build process.
So it's like a bouncer for your Docker image, only letting in the essential guests.
That's a great analogy.
So what kind of things should we be showing the door? What are some best practices for using the Docker ignore file effectively?
Well, a good rule of thumb is to exclude anything that's not strictly necessary for your application to run in production.
Hmm.
This might include things like log files, temporary files, build artifacts, local development dependencies, all that stuff that just adds unnecessary bulk to your image.
Right, so we want to avoid those Docker image potlucks where everyone brings a dish, but nobody wants to eat half of it.
Exactly. Keep it lean, keep it clean. A well-crafted .docker ignore file is your best friend in achieving that.
This is great stuff. I'm already starting to see how much more streamlined and efficient our Docker workflows can be. But before we go too far down that rabbit hole, I want to make sure we address a question that I know is on a lot of people's minds. Security.
Ah, yes, security. Always top of mind, as it should be.
Exactly. So how do we make sure our Docker files are contributing to, not detracting from, our overall security posture?
That's a great question, and it's one that deserves a deep dive all on its own.
I'm all ears.
But for now, let's focus on a few key principles. First and foremost, always use trusted base images from reputable sources. Don't just pull random images from Docker Hub without doing your due diligence.
Okay, that seems like common sense, but it's easy to get caught up in the excitement of a new project and forget the basics.
Absolutely. It's like building a house on a shaky foundation.
Yeah.
No matter how beautiful the structure, it's not going to stand the test of time. The same goes for your Docker images.
Solid advice. So, trusted base images, check. What else should we be mindful of?
Next up, minimize your attack surface. The fewer components in your image, the less there is to exploit. So we go back to what we discussed earlier about using a Docker ignore file, leveraging multi-stage builds, and generally keeping your images as lean as possible.
So it's not just about efficiency, it's also a security best practice. I like it.
Absolutely. And while we're on the topic of minimizing your attack surface, let's talk about running your applications as a non-root user.
Oh, right, the principle of least privilege. It's one of those things that everyone knows they should be doing, but it's easy to overlook.
It's true, but with Docker, it's actually quite simple to implement. By default, Docker containers run as root, which gives them a lot of power, maybe more than we really want.
That makes sense. So how do we create a less privileged user within our Docker image?
It's actually pretty straightforward. You can use the USER instruction in your Docker file to specify a different user and group for your application to run as.
So it's like creating a dedicated user account for your app.
Exactly. And then you can fine-tune the permissions to give it just enough access to do its job and no more.
Okay, that makes sense. So we've talked about trusted base images, minimizing our attack surface, and running as a non-root user. Any other security nuggets you want to share?
Let's see, we've covered a lot of ground. Oh, here's a big one. Scanning your images for vulnerabilities.
Ah, yes, vulnerability scanning. It's like giving your Docker image a thorough security checkup.
Precisely. And the good news is there are a bunch of great tools out there that can automate this process for you.
Okay, so it's not something we have to do manually.
Not at all. You can integrate vulnerability scanning into your CI/CD pipeline so that every image you build gets scanned automatically.
That's amazing. It's like having a security guard posted at the door of your Docker registry, making sure only the good guys get in.
Exactly. And these tools are getting more and more sophisticated all the time. They can detect a wide range of vulnerabilities, not just in your application code, but also in the underlying libraries and dependencies.
That's reassuring to know. So it sounds like we have a lot of options for building secure Docker images.
Absolutely. And the best part is, most of these security best practices go hand in hand with the principles of efficiency and maintainability that we've already discussed.
Right, it's not about choosing between security and efficiency. It's about finding that sweet spot where they both work together.
Exactly. When
Yeah.
you get it right, you end up with Docker images that are not only secure and efficient, but also a joy to work with.
Well said. And that's a great note to end on. We've covered a lot of ground in this deep dive on Dockerfiles. We talked about the importance of declarative infrastructure, the power of multi-stage builds, the magic of the Docker ignore file, and of course, the crucial role of security in every step of the process.
It's been a great discussion. I always enjoy geeking out about Docker files.
Me too. And I'm sure our listeners have learned a ton. But before we wrap up, I want to leave you with one final thought, something to ponder as you embark on your Dockerfile adventures.
I'm all ears.
We've talked about a lot of technical details today, but at the end of the day, a Dockerfile is more than just a set of instructions. It's a reflection of your development process, your values, and your commitment to building high-quality software.
That's a really powerful way to think about it.
So my challenge to you is this. Don't just treat your Dockerfiles as an afterthought, something you tack on at the end of the development cycle. Embrace them as a first-class citizen in your project.
I love that. Treat your Docker files with the same care and attention that you would your application code.
Exactly, because when you invest in your Dockerfiles, you're not just investing in your infrastructure, you're investing in the long-term success of your project.
Well said.
And with that, I think we'll wrap up this deep dive on Dockerfiles. A huge thank you to our expert for sharing their wisdom and insights with us today.
It's been a pleasure.
And to our listeners, keep experimenting, keep learning, and keep pushing the boundaries of what's possible with Docker.
So you can have one stage with a full JDK for compilation, and then a second stage with a slim JRE to run your application. You're essentially discarding unnecessary dependencies, resulting in a significantly smaller and more efficient final image.
Okay, that's slick. It sounds like multi-stage builds are all about optimization.
Yeah.
But are there other benefits beyond just image size?
Absolutely. Security is another big one. By minimizing the attack surface of your container, you're reducing the potential for vulnerabilities. Think about it. If you don't have unnecessary tools and libraries in your final image, there's less for a potential attacker to exploit.
So it's not just about efficiency, it's also about building more secure applications.
Precisely. And here's another interesting aspect of multi-stage builds. They can actually make your Docker files more readable and maintainable. You're essentially breaking down a complex build process into smaller, more manageable chunks. Each stage has a specific purpose, making it easier to understand and debug.
That's a really good point. I've definitely seen my fair share of Docker files that look like cryptic shell scripts. Multi-stage builds sound like a breath of fresh air in that regard.
They really are.
Hmm.
And speaking of readability and maintainability, let's talk about some Dockerfile instructions that are often overlooked but can significantly impact the quality and security of your images.
Ah.
For example, have you ever encountered the entry point instruction?
I've seen it around, but I'll admit I haven't fully wrapped my head around its purpose, especially in relation to the CMD instruction, which we use to specify what command to run when the container starts, right?
You're right. CMB is used to provide default commands for a container. However, entry point defines what executable should be run when a container is started from the image, essentially defining the container's main purpose. Let me illustrate the difference between entry point and CMD with an example. Imagine you have a Docker image for a simple Node.js application. You can use CMD node server.js to start your server, but if you always want to run your application with a specific tool like a process manager, you can use entry point. For example, entry point PM2 start, followed by CMD server.js. This makes your container more flexible as you can override the default CMD when running the container while ensuring that PM2 always manages your application.
That's a really practical example. I've definitely encountered situations where I wanted that level of control but wasn't sure how to achieve it. It seems like entry point and CMD working together offer a lot of flexibility in defining a container's behavior.
Exactly. And while we're on the topic of Dockerfile instructions, let's not forget about some lesser known but equally important ones. For example, the .docker ignore file. It's like the .git ignore for your Docker builds.
Oh, I've heard of Docker ignore, but I've never really used it. To be
Yeah,
honest, I'm a bit guilty of just letting Docker copy everything into my images.
I understand. But using a .docker ignore file can significantly improve your builds. By excluding unnecessary files and directories, you can reduce image size, which, as we discussed, speeds up builds and deployments. More importantly, it can prevent sensitive information from leaking into your images. Imagine accidentally copying your entire project history or local configuration files into your production image. A well-crafted .docker ignore file can help you avoid such scenarios.
That's a really good point. It's one of those things that seems trivial but can have a big impact on both efficiency and security. So what are some best practices for creating a Docker ignore file?
The key is to be as specific as possible. Think about what files and directories are essential for your application to run and exclude everything else. This might include log files, build artifacts, development dependencies, and definitely any sensitive information like API keys or credentials. Remember, smaller and more focused images are generally more secure and easier to maintain.
That's a great takeaway. We've covered a lot of ground today, from the fundamentals of declarative infrastructure to advanced techniques like multi-stage builds and the importance of a well-crafted Docker ignore file. What are some final thoughts you would leave our listeners with as they embark on their Dockerfile adventures?
Writing effective Docker files is an ongoing learning process. Embrace experimentation, explore the documentation, and don't be afraid to iterate. Remember, a well-crafted Docker file is a key ingredient in building efficient, secure, and maintainable containerized applications.
Couldn't have said it better myself. A huge thank you to you for sharing your expertise with us today. And to our listeners, keep diving deep, keep exploring, and we'll catch you in the next deep dive.